I don't wanna grow up, I'm a curious kid. The world has 100 questions I can play with. So I'll open my arms and eyes and wonder every day till the day I die. No one really knows why gravity exists.
Our speaker tonight, presenting the mysteries of sleep, is Professor Matthew Walker. Matt earned his PhD in neurophysiology from the Medical Research Council in London, England, and subsequently, in 2004, became an assistant professor of psychology at Harvard Medical School. He is currently professor of psychology and neuroscience at the University of California, Berkeley, where he directs the Sleep and Neuroimaging Laboratory. Professor Walker is the recipient of funding awards from the National Science Foundation and the National Institutes of Health. And in 2006, he became a Kavli Fellow of the National Academy of Sciences. His research examines the impact of sleep on human brain function, with a particular focus on the role of sleep in memory processing, neural plasticity, and emotional regulation. I got to warn you that before actually letting Matt grab the microphone here, I was going to tell you that if you are having trouble sleeping, I hope you look forward to listening to Matt. No, wrong message. We're going to enjoy Matt intellectually and maybe later tonight get a good night's sleep. Please welcome Professor Matt Walker.
Thanks, Tucker. Thank you very much. Can you all hear me in the entirely cheap seats at the back? Very good. So it's a great pleasure to be here, and thanks again to both Tucker and Juliana for the invitation to speak to you. And I'm going to start with a now standard disclaimer, which is that when most speakers look to their audience and they see people who are sort of falling asleep or nodding off, it can be profoundly disheartening. However, based on the topic of tonight's presentation, I'm almost going to actively encourage that kind of behavior from you, okay? In fact, knowing what I know, particularly about the relationship between sleep and memory, it's actually the greatest form of flattery for me to see people like you not being able to resist the urge to strengthen what I'm telling you by falling asleep. So feel free just to ebb and flow in and out of consciousness throughout the entire talk. I'll take absolutely no offense. And the talk itself is really going to come in two separate segments, and there'll be questions and answers after each one of those. I think I can hear this mic coming in and out. Can you guys? Is that the case, or is it fairly constant? Okay. In about 10 minutes, you'll wish that it had just complete. Bless you. Anyway, crashing on. So the talk is really going to come in two main segments. Firstly, I want to spend a lot of time telling you about what sleep is, the different stages, the different types, and how they unfold across the night. And the oddities around sleep too. And then for the rest of the talk, I'll tell you about the benefits of sleep when you get it and the detriments that happen when you don't. So first, I'll tell you about the role of sleep in learning and memory, and how sleep is essential both before and after learning in terms of grabbing information and then holding on to it long term. And then unfortunately, I'll tell you how that same process starts to fail as you get older. There's a silver lining to that story, don't worry, it's not all depressing. Then we'll have some Q&A, and then in the second half, I'll switch gears and I'll tell you that sleep is also important for, bless you again, inspiring creativity and offering novel insights. Then we'll go downstairs into the body, and I'll tell you that sleep is essential for many body processes, including immune health, and how there is a link between a lack of sleep and things like cancer. And then finally, we'll come back to the brain, and I'll tell you that sleep is also critical for your mental health, that sleep can prepare your brain, sorry, this is pretty bad, sleep can prepare your brain in terms of its emotional circuitry and get you ready for next day's social and psychological interactions. So that's the basic overview. Let's then begin with what sleep is. And I do love this image. you can just get a sense of the depth and the sort of quality of sleep that's happening here. And if we're going on this whole sort of savanna grassland animal kick, let me just take a quick side road for a second and show you the giraffe. What a bizarre design of evolution. Have you ever wondered how something that looks like this actually sleeps? Would you like to know how a giraffe sleeps? This is how a giraffe sleeps. Isn't that remarkable? And it tells us at least two important things. First, despite such bizarre anatomy, sleep will still find a way to be obtained by the brain. Second, and more generally, in every species that we've studied to date, sleep, or something that looks very much like it, has been observed. What that tells us is that sleep has fought its way through heroically every step along the evolutionary pathway. That must mean that sleep is essential at the basic biological level. And that's exactly what we're finding. And sleep, at least in mammalian species, has been broadly separated into two main types, as well as some of you may know. On the one hand, we have non-rapid eye movement sleep, or non-REM sleep for short. And non-REM sleep has been further subdivided into 4 separate stages, and they have been unimaginatively called stages 1 through 4. We are a creative bunch as sleep researchers, clearly. But they increase in their depth of sleep. So stages 3 and 4 are those deep stages of dreamless sleep, no dreaming. On the other hand, we have rapid eye movement sleep, or REM sleep, named not after the popular Michael Stipe pop band, but because of these bizarre horizontal shuttling eye movements that occur underneath your closed eyelid. And we've got no idea why your eyes move during this stage of sleep. It is the stage from which you principally dream, and I will come back to that in just a second, but your eye movements are not seemingly tracking the dream event. So we don't know why your eyes move, but they do, and that's where the name is derived from. And it turns out that these two types of sleep, REM and non-REM, will essentially play out in a battle for brain domination throughout the night. And that cerebral war is going to be won and lost every 90 minutes, and then actually replayed every 90 minutes. And I don't know if there's a problem with the sound. No, it's just a conversation. So these two types of sleep, as I said, are going to battle against each other. And that war, as I said, in humans at least, is won and lost every 90 minutes and then replayed. What that means is that we produce a standard cycling architecture of sleep. And I'll just show you what happens here. So on the vertical axis, you've got the different stages of sleep. REM here in this kind of red-pink color. And then the descending stages of non-REM. And we've got time of night along the horizontal axis. And I'll speed this up for you, but what you can see is that upon falling asleep, your brain goes on this delightful roller coaster ride in and out of these different stages of sleep. So you will first descend down into the light stages of non-REM, then down into the deep stages of 3 and 4 non-REM sleep. You'll stay there for about 70 or 80 minutes, and then you'll start to rise back up, and you'll have a short REM sleep period here in red. And then back down you go again, down into non-REM sleep and up into REM. And as I said, that cycle is standard. It's set to 90 minutes, and it repeats across the night. However, what changes is the ratio of non-REM to REM within those 90-minute cycles as you shift across the night, such that in the first half of the night, the majority of those 90-minute cycles are comprised of deep non-dreaming sleep, stages 3 and 4. Yet as you push through to the second half of the night, now that balance shifts. And instead, you're obtaining much more rapid eye movement sleep here in red, as well as a lighter form of non-dreaming sleep, stage 2 non-REM sleep. Now, let me just for a second come back to REM sleep, because as I said, REM sleep is the principal state from which you dream. And when you dream, it literally is a case of how your brain has gone completely out of its mind. In fact, all of you here, as long as you slept last night, you all became flagrantly psychotic. Now, before you reject my diagnosis of a nightly psychosis, let me give you 5 good reasons. Because last night, when you were in REM sleep and you were dreaming, you began to see things which were not there. So you were hallucinating. Second, you believed things that could not possibly be true. So you were delusional. Third, you became confused about time, place, and person. So you're suffering from disorientation. Fourth, you had wildly fluctuating emotions, something that psychiatrists will tell you means you're being affectively labile. And then how wonderful. You woke up this morning and you forgot most, if not all, of that dream experience. So you're suffering from amnesia. If you were to experience any one of those 5 symptoms when you're awake, you would be seeking psychological help. But for reasons, again, that we don't fully understand, it seems to be a normal biological and psychological process. One of the other fascinating features of REM sleep is this. Sorry, someone sounds like they're being murdered behind me, excuse me. Is REM sleep paralysis. Because it turns out that your brain, despite being frenetically active during REM sleep, will do something very different downstairs in your body, which is send a signal all the way down your spinal cord. So here we have the brain, which, as Woody Allen suggested, was his second most favorite organ of the body. And so front of the brain, back of the brain. And where those 2 types of sleep are generated and duke it out throughout the night is right here at the base of the brain. In fact, it's called the brainstem. And although during REM sleep we get strong bursts of activation up to this cortex structure that sits on top of your brain, there's another signal that's sent south down into your spinal cord. And that signal is going to paralyze what we call the alpha motor neurons in your spinal cord. They control all of your voluntary skeletal muscles. Why is this? It's very clever. Your brain paralyzes your body so your mind can dream in safety. Imagine what a bum idea it would be from an evolutionary perspective for you to be dreaming about sort of being the, this ultimate martial arts fighter. When your eyes are closed, you're not perceiving the outside world. You'd be taken out the gene pool very quickly on that basis. But that doesn't happen, luckily, in most of us. Unfortunately, there is a condition that can happen as we get older, particularly in males, where this paralysis fails. It's called REM sleep behavioral disorder. And as a consequence, you dream, but you don't block those signals downstairs in the body, and so you start to act out your dreams. Let me just show you a brief video clip of a patient who is suffering from REM sleep behavioral disorder. And I'll try and sort of narrate this, but it looks like he's awake. Wrong. He's, here he is. He's actually awake, and he's now fighting off intruders. He's completely asleep. He's in REM sleep. But you can see that violation. And just imagine being the spouse or the partner of these people. It's particularly challenging. Patients have ended up zipping themselves up in a sleeping bag every night for the past 10 years, chaining themselves to the bed when they've suffered from this disorder. People have in fact murdered their spouse in their sleep. It's very rare. Don't worry, but now it turns out it's not just humans that can suffer what's called REM sleep behavioral disorder. It's also any species that has REM sleep. Let me show you a dog suffering from REM sleep behavioral disorder. Running away, in place, it's being chased, starts to lift up, try and bite whatever it is that it's attacking, gets up and then runs into the wall, and then comes out. Desperately sad. So there's a part of the brain that degenerates with age, more so, as I said, in men than in women, and we lose that paralysis. By the way, that is some of the best evidence that we have yet that we are not the only species that dreams. It's hard to argue that that isn't a dream. I'm just going to move the mouse away because it's profoundly annoying. Okay, so that's the lack or the failure of REM sleep paralysis. There is a flip side to that coin, where REM sleep paralysis is in excess. So there can be rare circumstances, and this is not pathological, where your brain starts to wake up in the morning, but the brain forgets to turn off the paralysis. So you start to become aware of your surroundings, and you can't open your eyelids, though. You can't move, you can't shift. It's usually associated with a sense of anxiety and dread, sometimes that there's someone else there in the room. Many of you may have experienced this. About 25% of the population will have it. It's about as common as hiccups. And it turns out that this, what we call persistence of paralysis upon awakening, accurately explains most, if not all, of these things. Alien abductions. When was the last time you ever heard of someone being abducted by aliens in the middle of the day during a meeting? You hear this sound like shh. You think, what was that? Well, I believe James was just abducted by aliens. Did everyone see that? No, it never happens like that. It's normally at night. You're in bed. You describe being paralyzed by some agent that was injected into you. You can't fight back. You can't shout. There's a sense of dread and an intruder. Fascinating stuff. So that's a little bit about what sleep is and some rather odd things that go around the periphery. Now let me start to tell you what sleep does for both your brain and your body. And let me start here with the need for sleep before learning to get your brain ready to initially acquire and soak up new information, getting your brain almost like a dry sponge. And that if you don't sleep, it becomes waterlogged and you can't lay down new memories. So, excuse me. So in this first experiment, what we're going to do is test the hypothesis that pulling the all-nighter is a good idea. How do you do that? You take two groups of participants, a sleep group and then a sleep deprivation group. Now, both of them are awake across the first day, but then across the following night, those in the deprivation group here in red, we keep them awake in the laboratory under full supervision, no naps, no caffeine. It's miserable for us and for them. It's miserable for everyone. Whereas the sleep group, they get a full 8 hours. And then both of them are awake across the second day. And then at the end of the second day, we have them try to learn a whole bunch of new facts that they try and cram into their brain. And then we're going to test them to see how efficient that learning has been. But instead of testing them immediately after learning, we actually wait until 2 full recovery nights of sleep before we test them, so that any measure of memory that we get is not confounded by them simply being too sleepy or inattentive to truly recollect what they may have learned. Is that clear to people? Okay. And so that's what you're looking at here on the vertical axis, the efficiency of learning. So the higher up you are, the better you are. And when you put these two groups head to head, what you find is that under conditions of sleep deprivation, there is a quite profound 40% deficit in the ability of your brain to make new memories without sleep. This should perhaps be frightening considering what we know is happening to sleep in our education populations. Just to put this in context for any students out there, it's simply the difference between acing the exam and failing it miserably. Okay? Now, of course, these are just performance data. We don't actually know what's going wrong in the brain. So we've actually repeated this same experiment, but this time subjects are actually inside one of these, an MRI scanner. And we're able to take snapshots of brain activity each time they try to learn something new. So we can produce these attempted maps of learning in the deprivation group and in the group that's had a good night of sleep, and then subtract one from the other to see what the difference is. And when you do that subtraction, what you find is a highly selective but highly significant impairment in this part of the brain that I'm circling for you here. It's called the hippocampus. So just to unpack this figure for those of you not familiar with MRI images, this is as if I've sliced from ear to ear and you're looking in from the front. So this is the top of the brain, the base of the brain, left and right side. And I'm circling for you the left hippocampus and the right hippocampus. You have one of everything on each side of your brain. You have a left and a right of everything in the brain. It's a mirror image. And these cool blue blobs demonstrate that in those people who are sleep deprived, there was a significant lack of activity compared to a nice, strong learning-related signal in this part of the brain in those people who've had a good night of sleep. Why is this important? Well, it turns out that the hippocampus is the quintessential reservoir for where your brain creates new memories. In fact, if you want to know what life is like without a functioning hippocampus, just watch the movie Memento. How many people have seen this movie? Yep, most all of you. For those of you who haven't, you should watch it. It's a great movie. I won't spoil a punchline, but this gentleman suffers brain damage. And from that point forward, he can no longer make any new memories. He is densely amnesic. The part of his brain that is damaged is the hippocampus. It is the very same structure that sleep deprivation will attack and then block your brain's capacity for new learning. Let me for a second just come back to this section of the data, the group that got a good night of sleep, because we can ask a different question. What is it about the quality of the sleep that they're having that seems to refresh each and every day their learning capacity? And what we found, because we record the sleep during this night, is that it is stage non-REM sleep that's important, that non-dreaming sleep, and particularly electrical bursts of brainwave activity called sleep spindles that are the hallmark feature of this stage of sleep. And these are short synchronous bursts of electrical activity. They last for about a second, these little champagne cork bursts. And what we found is that the more of these that you have, the greater the degree of restoration of your memory function the next morning. So each of these dots represents an individual participant in the study. And what you can see is that those people who have more of these sleep spindles during the night, excuse me, show the greatest degree of memory restoration the next day. And we believe that these sleep spindles are essentially taking the USB stick, which is the hippocampus, and shifting those files from the prior day onto the hard drive of your cortex, so that you wake up with a renewed capacity of your hippocampal USB stick for new learning. Now, it's important to understand not just the bad that's happening without sleep, but the good that happens when you get it. Because we're starting to understand what happens when these sleep spindles fail in diseases and specific neurological conditions. And let me give you just one of them, which is this: aging. Don't worry, for those of you who are older, I am rapidly catching you up, I guarantee you that. Why is this interesting, though, this question? Well, we know that as we get older, of course, our learning and memory capacity starts to deteriorate. But we've also known for many tens of years now that your sleep physiologically starts to deteriorate as you get old, including these sleep spindles. In fact, by the time you're 70, you have about a 40 to 50% reduction in the amount of sleep spindles compared to when you're 20. And just recently, in this past year, we finally published evidence that suggests that these two things are not simply co-occurring, they are significantly interrelated. And that the loss of these types of brainwaves during sleep in the context of aging is an underappreciated factor that contributes to memory decline as we get older. Now, although that may sound depressing to you, there is a silver lining. Although there are other factors that contribute to memory problems with aging, like blood flow or changes in the structure of the brain, the upside with sleep is that it's modifiable. We can actually treat sleep. And we're now trying to modify sleep in older adults using things like electrical brain stimulation to see if we can give back into the brain these sleep spindles, and as a consequence try and restore the contribution of sleep to memory in older adults and hopefully on into dementia. So I will, I think, pause there for a second and finish the first half, and maybe we can take some questions and answers and see how people are feeling.
I'll come around with the mic. Is that on?
Hello.
Could you redefine exactly what a sleep spindle is again?
Yeah, so the question, if you didn't hear it, was, can I redefine what a spindle is? So sleep spindles are these bursts of activity, these short bursts of activity that happen up in your cortex. I'm being told to move into the light for the camera. They usually tell you to stay away from the light, but I guess I'm not quite that age yet. So these sleep spindles are these short synchronous oscillations, and they coincide with activity deep in the brain in the hippocampus. And we believe that they act like a therapy session between your hippocampus, which is like your USB stick, and your cortex, which is a hard drive. And it's this therapy session that then transfers information from one location to the other, and as a consequence results in the restoration, the freeing up of memory resources when you wake up in the morning.
If your brain paralyzes your body during a dream, what is sleepwalking?
Great question. So if your body is paralyzed during REM sleep, then what's all this sleepwalking, sleep talking business? It turns out that sleepwalking and sleep talking is not related to REM sleep. It comes from non-rapid eye movement sleep. And what happens is that you're in the deepest stages of non-REM, stages 3 and 4. And for reasons that we don't understand, the brain seems to get an ejection signal, a burst of activity, and your brain tries to go from the basement to the penthouse of wakefulness, but gets stuck somewhere in between. And as a consequence, even though your brain waves look like they're in deep slow wave sleep, the person is up and about and they're performing very standardized, routine, well-rehearsed behaviors, going over to the refrigerator, opening the door, a glass to the mouth. And if you wake people up from these sleepwalking episodes and you say, what was going through your mind? They will tell you nothing, because they weren't dreaming. There was no dream that was occurring. So sleepwalking and sleep talking is an anomaly that happens from deep non-REM sleep, where your brain gets sort of ejected out of it, but never makes it fully to wakefulness.
Is there any difference in the movement of the eyes in blind people versus sighted people during REM sleep?
That's a very interesting question. So in terms of the eye movements, it really depends on the nature of the blindness. So if the blindness is caused by damage to the visual cortex at the back of the brain and the eyes are unaffected, then you have standard rapid eye movements. But if the problems are in the what we call the extraocular muscles, which control the eyeballs, then you will have some deficits. I will also note that congenitally blind people tend not to dream visually. However, people who have suffered blindness either through problems at the level of the eye or at the level of the brain, early in the course of their blindness, they will still dream visually. And in fact, it's immensely therapeutic for them. It's one of the few times in their conscious life that they get to re-experience vision. But unfortunately, as the blindness continues and takes a hold across the years, the visual dreaming dissipates.
So I have maybe a two-part question. I actually have an app that's called Zeo, what
Yes.
measure, and it's great. And what I actually find is that I actually feel better when I don't have as much REM sleep. So my question to you is there a way, or are you guys working on something to induce, as soon as you fall into REM, to come back out of REM in order for your hippocampus to get more strength?
So firstly, we're starting to understand, as you'll sort of see later in the talk, that REM sleep serves many vital functions. So the idea that REM sleep shouldn't be obtained would be a bad idea. You should let your body physiology and your brain figure out what you need from one night to the next. And your brain and your body will demand on the menu at night different types of sleep depending on what you've been doing. So sleep is reactive based on what you've been doing during the day. So the idea that there is only one important type of sleep is a misnomer. And we shouldn't try to self-medicate or self-manipulate our own sleep. Trust me, millions of years of evolution have figured that out for us, and we should just let it do its job. Yep.
Are the effects of long-term sleep deprivation reversible?
So are the effects of long-term sleep deprivation reversible? It's a tricky question to answer because ethically it's a difficult experiment to do. Even in animals now, there are rules that would probably prohibit that for probably good reason. What we certainly do know is that people who have suffered a long duration of a sleep disorder, like sleep disordered breathing, which is called apnea, snoring, there are physical changes within the brain, and they correlate with how long you've had that sleep disorder. Structural changes, parts of your brain will shrink because of a lack of sleep, because of what's called oxidative damage. So we certainly know that those structural brain changes aren't recovered as a consequence of then treating the disorder. You're simply going to stop any further deterioration from happening. What I will note, however, is that a lack of sleep is fatal. Rats will die as quickly from sleep deprivation as they will from food deprivation. That's how essential sleep is. And the experiment has also been done in humans. And you should all look at me and think, no, it hasn't. Not by experimenters, but by an unfortunate experiment of nature. There is a very rare genetically inherited disorder called fatal familial insomnia. And the title kind of gives it away. So what happens is that your brain, particularly the centers that control sleep, start to deteriorate. And you develop a severe insomnia. And then after about 6 months, you cannot sleep. No matter how much medication is pumped into you, tranquilizers, sedatives, you will not sleep. And then between about 12 to 18 months, you die because of a lack of sleep. So it truly is that essential.
Can you address oversleep? Like, some people just sleep 9, 10, 12 hours, and also make-up sleep when people are sleep deprived. How effective is make-up sleep? So the two kinds of oversleep.
Yeah, great question. So firstly, there is something called hypersomnia, which is excessive sleeping. If you look at the literature, it turns out that it's actually tricky to make that, I'm starting to lose my voice it seems, make that diagnosis. If you look at the data, it seems that people are simply staying in bed longer, but they're not actually sleeping longer. So in depression, one of the features is sometimes too much sleep, it seems. But again, if you really look at the data and the studies, it seems to be too much time in bed, which is not necessarily too much sleep. So there's still a lot of controversy around even the notion of hypersomnia. What about restful wake? So certainly they could simply be lying there awake but resting. What seems to be more the case is that people are just not motivated to engage with the daily activities. That seems to be the case for depression, causing the hypersomnia. I'm going to have to take a drink of water. I fear I may lose my voice for the second half, so hang on a second. Don't worry, thank you. I've not forgotten the second part. I'll hold on to this. There's a great quote by, I think, Steve Wright, the comedian, who's on stage and he's getting dry. And he said, do you realize that your body is 99% water, which means that you're 1% away from drowning? And then he picks up a glass of water and he looks and says, I like to live dangerously, and then swigs his water. So anyway, sorry, your second question, which is which is about rebound sleep. You do have significant rebound after you've been sleep deprived. It turns out that your brain never makes back up on the rebound night all of the sleep that it lost on the night before. So it has some capacity to try and get some sleep back, but it's never able to get everything back that you need. Why is that? Why don't we have that mechanism? The answer is very simple. Human beings are one of the few species that deliberately deprive themselves of sleep. In other words, evolution has never faced the challenge of having to make up sleep, so there is no good mechanism for it. So yes, there is definitely a rebound that we see, depending on which type of sleep you lose, but you can never make back up all that you've lost, even if you continue to track sleep 2, 3, 4 nights later.
Why do we not stay in REM sleep? Why do we fluctuate between going in REM sleep, out of REM sleep, in REM sleep, back and forth?
So this is perhaps one of the greatest mysteries of the field of sleep. Why don't you just have all of your non-REM sleep first and then all of your REM sleep second, or vice versa? And it's remarkably constant within individuals and across species. Nobody has an idea. Nobody has an answer. So we've learned, and I'll show you later in the talk, about the different functions that each of the different stages of sleep serve. But what we're missing, what we're suffering, is almost like a hemi-neglect in the field of sleep. We don't understand why it's structured the way it's structured. It's highly non-linear, as you saw. You have a massive amount of deep sleep first, and then it decays. And then REM sleep does exactly the opposite. It ramps up exponentially. Yeah, so when we're not in REM sleep, as you said, that's when sleep spindles can happen. They happen during non-rapid eye movement sleep. But don't be fooled that non-REM sleep and spindles are the only important thing. It's the whole shebang. You need both types of sleep. They all serve different functions.
First of all, thanks for doing this. Second of all, how do you differentiate between the stages of non-REM sleep, and why are naps so good for us, like short naps, for example?
Yeah, so the way that we differentiate different stages of sleep is based on the brainwave activity. So as you're going into light non-REM sleep, I'm just going to put my, thank you. So when you're awake, your brain is doing very fast, frenetic, what we call oscillations. In other words, the waves of your brain are going up and down many, many times a second, 60, 70, 80 times per second. When you start to drift off into sleep, the brain waves start to slow down. When they've slowed to a set predefined amount, we start to suggest that you're in light sleep. Then they slow even further, and they get bigger, and they get lazier, quote unquote. So that's how we define different stages of non-REM sleep, by the speed of the brain waves and how large and how slow they are. So the depth of that deep sleep is really very slow brainwave activity. It looks not dissimilar to coma.
Quick question about apps.
Oh, sorry, napping. You can tell I had a good night of sleep last night. So we have certainly done studies with naps, and naps can give, in terms of learning and memory, almost as much benefit as a whole night of sleep. Now, the naps in our studies are 90-minute naps. They're not your 10-minute power naps. The reason is so that we let people go through a full 90-minute cycle so they can get both REM and non-REM. Sorry, they like the nap story apparently behind me. But we've also found that as you start to scale naps back, you can still get benefits after maybe 20 minutes. Now, the question then is, why do we get that? Because none of us usually sleep in that way. The way that the majority of industrialized nations sleep is what we call monophasically, which is one long bout of 7 or 8 hours at night, and then we're awake for 16. However, we may not have been designed to sleep that way. Because if you can track people's physiology, in the afternoon, after lunch, maybe 2, 3, 4 in the afternoon, everybody has a physiologically measurable drop in your alertness. It's that thing where you're at a meeting in the afternoon and everyone's around the table and you start to get these head nods. You know, it's not that people are listening to good music. What's happening is that they're falling prey to a naturally predisposed, genetically hardwired drop in your alertness. And if you look at cultures that have not been touched by electricity, many of them will sleep biphasically, about 6.5 hours at night, and then they'll usually have that siesta-like activity in the middle of the afternoon. So we may not be sleeping the way in which we're sleeping, and I'll point a finger at a particular individual in the next segment of the talk as to why that's the case.
Next, just a question about iPhone apps or smartphone apps and how effective they are at actually measuring the kind of sleep that you're in. And then in addition to that, does it matter when you wake up? Sometimes they'll say, oh, you have to wake up in this certain phase of sleep. Does it matter? And is it accurate?
Yeah, so I think the first question, just correct me so I heard, about these sort of new apps that you can download. So they are getting increasingly better. The way that those apps tend to work is that they use the accelerometer that usually defines what you're doing with the phone. And remember the paralysis of REM sleep? You place it on your mattress, and during non-REM sleep, you move around a little bit. But when you go into REM sleep, you're paralyzed. So now the app knows, okay, it's likely that you're in REM sleep, and so on and so forth. That's how they can kind of tell non-dream sleep from dream sleep. The problem is that they're not really accurate much beyond that. Right now, what you need are sensing devices on the brain that also measure the eye activity and the muscle activity. And that's why the Zeo, which was mentioned before, is a headband that essentially has an electrode that picks up your brain activity, your eye movement activity, and your muscle activity. And using those three signals, you can more accurately define the different stages of sleep. So I think the future is portable sleep monitoring, and we will soon start to become these neurotics of the sleep world. You know, as we're sort of, you know, I was back about 5 years ago, I was working with this company, Zeo, and we had some of their devices, and I had some friends staying with me at the time, and I would give them the Zeo because I just always wanted data. I just wanted to even figure out my friends were sleeping. That's how weird I am. And they got incredibly competitive. They started to get upset at each other because one of them had a 98% sleep efficiency, the other only got 96. And they were saying, I'm going to beat you down tonight in terms of sleep efficiency. I'm going to nail you. So it's so interesting in this competitive nature what will happen. So I hope it doesn't go that route where we start to get so focused on our sleep. I think your other question was... when you wake up. Good question. The data isn't that clear yet, but certainly it seems to be that when you wake up out of REM sleep, for example, it takes a while for your brain to get back up to operating speed. There are parts of your brain that are very active during REM sleep, but there are other parts of the brain that are profoundly impaired. And those impaired regions are regions that control logical, rational thought, human thought. So as a consequence, when you wake up, especially out of REM sleep, you have what's called sleep inertia. Ooh, but it sounds great, but it's miserable. And that's why you kind of need, you know, the 2 cups of coffee before you're even going to have a conversation with me, let alone tell me about what we're going to do during the day. So there is an inertia effect, and it may be better to wake up out of stage 2 non-REM sleep rather than REM sleep. But the data it's not clear yet.
What about mindful meditation when you wake up while you're still in bed?
So what about mindful meditation was the question. It turns out that meditation, if you look at the patterns of brainwave activity or you put people in the scanner, the patterns of brainwave activity are different. So meditation isn't sleep in terms of a neurological signature. Now, it's not to suggest that meditation couldn't offer similar benefits to those that sleep provides. But if it does, and we played around with this, but the data wasn't that clear to basically put meditation head-to-head with sleep, even if meditation does offer similar benefits, my suspicion is that it arrives at those benefits through a neurologically different pathway because the patterns of brainwave activity are so different.
Yeah, I read this year that there's not only dreaming in the REM state, but there's non-REM phase, and it has a characteristically different psychological function. Can you clarify the non-REM versus the REM dreaming in terms of the anxiety and depression that's been correlated to one versus the other? One is more of a restorative, creative phase, and the other is more of a problem-solving phase.
So certainly it really depends on how you define dreaming. If you define dreaming as any report of mental activity when you wake someone up, then we dream in many different stages of sleep. But as you said, the characteristic nature of dreaming is very different in non-REM sleep from REM sleep. What do I mean? When I wake you up out of non-REM sleep, lighter stages, during the deep stages, it's almost a 90% certainty that you won't report anything going through your mind. From lighter stage 2 non-REM sleep, you tend to be what we call sleep thinking. So you don't have mental images. You kind of just say, well, I was just kind of waiting until the experimenter was going to come into the room and wake me up again. But they were asleep. We could see that. But they were just thinking. Whereas when you get to REM sleep, now the floodgates open. It's bizarre. It's hallucinogenic. It's a rich narrative that flows. So it all depends on your definition, but those two things seem to be very different. How dreaming relates to mental illness we still don't understand. We're still trying to figure out how sleep relates to mental illness. And I'll show you some data that I think argues that there's a very intimate association. But how dreaming above and beyond sleep stages relates to mental illness is still open for a lot of debate and theory.
Thank you, Matt. We'll take a quick break. Yes, please.
All right, let's get back in session here. Professor Walker did not just get a break at all. Shame on you for not letting him take a nap. Please, let's quiet down, please. A little quiet here. Please, I need to have a show of hands, please. Raise your hand if you learned about this event through either the website or the newsletter of Ask a Scientist. How many folks through Ask a Scientist? Great. How many of you learned about this event through Wonderfest newsletter or website? Great. And how about the legendary Sci Schmooze newsletter? We have two Sci Schmooze authors here, Herb Masters and Bob Sider. Sci Schmooze? Okay, well maybe you can go to Bay Area Science, help me, the website, bayareascience.org, and check out, subscribe to the newsletter called Sci Schmooze. It's a great way to learn about science events all around the Bay Area. Thank you, Herb and Bob, for, yeah. Now, we have also how about just word of mouth? How many folks found out about this by word of mouth? All right. Well, now that's not enough people. You guys who are here and you like these events, you see what great work Professor Walker is doing. If you support Ask a Scientist and Wonderfest and you don't want to give money or you want to help the money you've already given, please spread news of these two good organizations. All right. Please welcome Professor Walker back. Here he comes.
Thank you very much. And there was a delightfully kind individual in the audience who've given me a whole sort of menthol suite, so thank you. It disrupts your sleep at night, by the way. But no, it doesn't. I'm kidding. So I think the sound is going to be the music. There we go. Great. So in the second half, I'm now going to shift on to, again, sleep for the brain. I'll speak about creativity. Then we'll speak about the body, and then we'll return back into the brain at the end for sleep and emotion. So let me first speak about sleep and creativity. Because what we found is that sleep doesn't simply just grab a hold of individual memories and strengthen them across a night. So it's not just sleep before learning that you need. You also need sleep after learning. Just as you've created a Word document, you need to hit the save button. Sleep is very good at hitting the save button on those newly created single Word documents. But as I said, we've started to realize that sleep is much more intelligent than we ever imagined. Sleep can actually synthetically associate new memories together and come up with novel creative insights to problems that you've been facing in your waking life. Let me give you one example. So in this study, you're going to perform what's called the numeric number reduction task. It's one of those tests that psychologists love to administer and participants hate to perform. So you as the participant, you're going to see lots and lots of these number strings. And you can see that there's essentially only one of three numbers that are in these strings, and you're going to see hundreds of these. And your job is to work through these problems from left to right and come up with a final solution. And one of the ways that you can solve these problems is using some rules that I'll give you. And there are essentially only two rules. And I'll work through one of these problems with you just to show you the rules. So we're going to take the first number and compare it to the next number. Here's the first rule. If the next number in line is the same as the one that came before, I want you to write down the very same number. So take a 1, compare it to the next number, same or different, it's the same, so we write down the same number. Very good. Now we take this number and we compare it to the next number in line. Is it the same number? If it's the same number, write down the same number, but it's not. And here's the second rule. If it's a different number, I want you to write down the only other remaining number in this string, which would be a number 9. So let's do it again. Take a 9, compare it to a 4. Same or different? It's different. Write down the only other remaining number, which would be a 1. 1 to a 9, same or different. It's 4. 4 to a 4, it's the same, so write down the same number. 4 to a 9 to 1, 1 to a 4. Oh my goodness, is it boring and laborious. I mean, some people will almost lose the will to live in the experimental room when you're doing this. Now, what's interesting, and this is how the experiment works, you heard me say one way to solve these problems is using these rules. Because there's another way. There is a hidden shortcut. There is a cheat. And if you figure it out, you can start to blow through many more of these problems. Here is the hidden cheat, which is that no matter what number string that you're doing, and as I said, you see hundreds of these, which are different numbers, there's something common across every one of them, and it is this, that the second thing that you produce is always the final answer. So if you, as I said, if you figure this out, all you need to do is work up to this point in every one of the problems, and then you've got the answer. So you shortcut the rest of it, and you write it down. So what we can now do is we can expose a whole bunch of participants to these problems, and then we can bring them back 12 hours later, and we can expose them to a whole new set of problems. And at that 12-hour second exposure, we can determine what percent of those participants have developed insight into that hidden rule. But here's the trick. For half of those participants, that 12 hours of time was spent awake across the day. Whereas for the other half, that 12 hours contained a full 8-hour night of sleep. So essentially what we're going to do is put wake and sleep head to head in this sort of Coke-Pepsi challenge to see which one wins out in terms of creativity dominance, okay? So what you're looking at here is the proportion of participants in each of those two groups that went on to develop the insight that inspired creative knowledge at that 12-hour later point. So if we look at the people who stayed awake after being exposed, what we see is a little less than 25% of them went on to develop that understanding. It's not particularly impressive. What about the sleep group? Were they better, were they the same, or were they worse? And of course, they were better. But it was by how much better that was striking. This is how much better this group was who slept. Almost 60% of participants after a night of sleep came back to develop this hidden understanding, this creative solution. And what we've been finding is that some, not all, but many of these creative-like benefits from sleep are emerging from this rapid eye movement sleep, dream sleep, perhaps not surprisingly. It's almost as though sleep and perhaps dreaming is like group therapy for memories. Sleep gathers in everything that you've been exposed to during the day. Everyone gets a name badge. And sleep starts to force you to speak to people, not at the front of the room, that you think you've got obvious connections with, but maybe those folks at the back of the room, those wacky guys that you think you've got no association with whatsoever. It turns out you may have an interesting connection. Because when you start to fuse things together that shouldn't normally go together, but offer marked advances in evolutionary fitness, it sounds like the basis of biological creativity. And that's exactly what we're seeing a function of REM sleep in particular. So I should note that, by the way, when I present this evidence, sometimes people will say to me, well, aren't there those sort of creative genius types in history who are supposed to have not been long sleepers or were even short sleepers? And one of them that's often quoted to me is this gentleman. Does anybody know who this is? Thomas Edison, who in fact has a lot to answer for in terms of how we're sleeping, but let's set that aside for a second. Edison, clearly brilliant man. He was supposed to be a short sleeper. Now, we'll never know the truth behind that statement, but even if he was, it turns out that Edison was a habitual napper during the day. Here he is after what looks like a pretty good garden party. Here he is on his inventor's bench. In fact, it turned out that Edison understood the creative brilliance of sleep, and he used it as a tool. Here's what he would do. He would sit at his desk and he would place a pad of paper and a pencil next to him. Then he would take a metal saucepan like this one behind him. He would turn it upside down and place it underneath the chair. Then he would take 2 steel ball bearings in his hand and rest the back of his arm on the chair. And then he would start to relax back and fall asleep. And so he didn't go too far into sleep. What would happen is that the muscle tone would relax. He would release the steel ball bearings. They would crash on the saucepan underneath him, wake him up, and then he would write down all of the ideas that he was having. Isn't that genius? So no wonder nobody ever tells you that you should really stay awake on a problem. Instead, what do they tell you to do? Sleep on a problem. And it turns out that in every language that I've inquired about to date, this phrase, or something very similar, sleeping on a problem, seems to exist. What that means is that this benefit transcends cultural boundaries. It's common across the globe. I should also note, by the way, that we, the British, we say you sleep on a problem. It turns out that the French translation is much closer to sleeping with a problem. I think it explains so much about the difference between the British and the French. Anyway, before I get myself into trouble, it's so clear. So, sleep, of course, is of the brain and it is for the brain. But there are also immense benefits that are obtained by the body in terms of sleep, and remarkable dysfunctions that happen within the body when you're not getting sleep. In fact, we now know that a lack of sleep is strongly linked to cardiovascular dysfunction, metabolic disease, glucose dysregulation, to the point where sleep loss will set you on the track towards type 2 diabetes. And also, there is, of course, a critical link between sleep and your immune health. Sorry, I'm just going to have a quick shot of water. Do ask me about sleep and alcohol at the end. Someone remind me. There's a fascinating story there, which I'm sure as all abstainers you're not interested in, but your friends maybe. So there is a link between sleep and immune health. And let me just give you one example. I could have given you an example in any one of those body system domains, but I'll focus on immune health and one example here. So let me introduce to you these things, natural killer cells. They are a first-line defense agent of your immune system. You can think of them like the Secret Service agents of your immune health. They are very good at targeting foreign agents, particularly viruses and tumors, and destroying them. So the natural killer cells are the blue objects that you can see in this image. And what they are attacking here is a malignant tumor mass. They're very good at doing this. They will latch onto the tumor, they will release proteins into it that will then destroy the tumor. So what you want is a very virile immune system, particularly involving these natural killer cells. Unfortunately, that's exactly what you don't have when you haven't been sleeping well. Let me show you the evidence. This study is going to be a 4-day, 3-night study. So on the first night, you're going to have a full 8 hours of sleep. And then the next day after that full sleep, we're actually going to sample your blood and we're going to assess the amount of natural killer cell activity that you have in terms of your immune system function after a good night of sleep. Then out here on day 3, we're going to sleep deprive you, but we're not going to totally sleep deprive you. We're just going to limit your sleep to 4 hours. So this is a quote-unquote bad night of sleep, as it were. And then, once again, we're going to sample your blood, and we're going to assess one more time your natural killer cell activity. So every participant acts as their own control, and we get a baseline of your immune system health after a good night of sleep, and then after a bad night of sleep. And then I'm going to compare the amount of immune health that you have out here on day 4 relative to your baseline on day 2. So we're going to look at a percent change in your immune system. Is that clear to people? So that's what you're looking at here on the axis, the percent reduction, and it is a reduction. You can see from the axis the direction of the result. It's only going one way, and it's a bad direction. It's a reduction. But once again, it was the severity of reduction that was dramatic. This is the magnitude of immune deficiency that you suffer with one bad night of short sleep. A 70% deficit. That is a demonstrable impact on the veracity of your immune system health. And again, that's just one night of sleep, one bad night of sleep. Imagine the chronic long-term effects. In fact, we now know that there are strong links between a lack of sleep and the risk for certain types of cancer. Here's a paper that was published a few years ago demonstrating that short duration of sleep increases your risk, for example, of colorectal cancer. Indeed, the science associating lack of sleep with cancer is so strong that recently the World Health Organization classified shift work as a probable carcinogen. Because of the disruption of your sleep-wake rhythms due to shift work and the reduction in your sleep, that is the biological impact. And that is the serious nature that the World Health Organization will now treat a lack of sleep in terms of this cancer risk. So remember when you were getting sick a lot and you sort of speak to your mother on the phone and she would say, well, are you sleeping enough? She was absolutely right. Her intuition was spot on. And all scientists like me are actually doing is just putting the data behind everything your mother ever told you about sleep. My mother has probably written almost all of my grants in my scientific career when I was probably about 6 or 7 years old, and I wish I'd remembered them. So let me finally finish by coming back out of the body, upstairs into the brain, and tell you that sleep is also essential, not just for learning and memory, but in terms of stabilizing your emotional and mental health, preparing you for next day's social and psychological interactions. Because I think many of us have a sense that these two factors of sleep and emotion interact in some meaningful kind of way. It's that idea of a parent holding a child, the child is crying, and they look at you and they say, well, they just didn't sleep well last night. As if there's some universal parental knowledge that bad sleep the night before equals bad mood and emotion reactivity the next day. We also know, by the way, clinically that these factors are intertwined because almost every psychiatric disorder displays co-occurring abnormalities of sleep. And what we've been trying to do is unpack the underlying brain mechanisms that support this association. So when you think you've got two factors that are interacting, one way to test that interaction is to manipulate one of the factors and then observe what happens to the other. So in this experiment, we're going to manipulate the factor of sleep again by dialing it down and blocking it with deprivation and seeing if as a consequence we can trigger an amplified emotional brain reaction as a consequence. So a very similar design to one that I showed you before, a sleep group, a sleep deprivation group. Deprivation group, we keep awake. The sleep group, they get a full 8 hours. Then the next day, we wedge them inside the MRI scanner and we perform an emotional challenge task with them. So here, inside the scanner, they're going to see 100 standardized psychological picture slides that range in a gradient from being emotionally neutral to increasingly negative and unpleasant. And I'll just show you some examples here. They actually get a lot worse than this. They get pretty gruesome. I won't show you those. There'd be sort of reactive vomiting in the front row of dinner, and we don't want that. But you get a sense of the design. Then we can ask a very simple question. What in the brain shows increasing reactivity in response to increasing emotional negativity? And the structure that we're going to focus on here is this structure in red. It's a structure called the amygdala. It's buried deep in the middle of your brain. You have a left amygdala and a right amygdala. And it's the emotional centerpiece of your brain in terms of reactivity. Sorry, I'm just chewing this thing. Keep watching, it's hypnotic. So if we look at this part of the brain in those people who've had a good night of sleep, what we see is that there is a reaction in this part of the brain in response to those negative experiences. And that's these little hot spots here. So again, this image is the same that I showed you before. You're looking into the front, top of the brain, bottom of the brain, and I'm circling the left and right amygdala here. And you just have to take it from me that this amount of hotspot activity is a modest reaction. It's not an excessive reaction. And that's what you want. You don't want no reaction. You just want some reaction. When we look at the sleep deprivation group, rather than seeing impaired brain activity, which had been, as you'll remember, the story with learning and memory, when it comes to emotion and sleep deprivation, you see exactly the opposite. In fact, here what we saw was a 60% amplification of your emotional brain reaction without sleep. And you can just focus on those regions. You can kind of go into them, zoom in, and you can just see that. You don't need statistics or bar graphs to see the dramatic difference in reaction when you're sleep deprived. But for us, the much more interesting question was actually why? Why was your emotional brain so excessively reactive without sleep? And we performed some additional analyses, and what we found was that when you've had a good night of sleep, there is a nice refreshment of the connection between the amygdala and this part of your brain here in green. It's called the frontal cortex. So this is now removing one half of your brain, and we're looking in from the side, the back of the brain, the front of the brain, the top of the brain. And this part of your brain, the frontal cortex, is like the CEO of your brain. It's very good at making high-level, top-down executive decisions and choices. And we know that it regulates the amygdala. So in other words, with a night of sleep, you had this nice, strong connection, and as a consequence, this nice balanced mix between the emotional gas pedal and the brake. Frontal lobe brake, emotional amygdala gas pedal. However, in the sleep-deprived group, what we found was that that connection had unfortunately been severed. And as a consequence, you got this almost Neanderthal-like amplified amygdala reaction without sleep. So as a consequence now, it's as though you're all emotional gas pedal and no frontal lobe brake. That's the reason that you sort of have those emotional meltdowns when you haven't been sleeping sufficiently. By the way, it turns out it's not just sleep researchers or their participants who know this. It turns out other professions know it and almost use it as a tool. What do I mean? Actors. I'm going to show you a clip of an interview. This is from inside the actor's studio with the now unfortunately late James Gandolfini, incredibly powerful actor. And one of the questions he's asked is, what are the techniques that he uses to try and achieve such emotionally powerful acting within those difficult scenes? What he says is fascinating. Let me play it for you.
Some of the things I'll use to get angry are lack of sleep will piss you off to no end. Sleep 2-3 hours a night for 2 nights before you have a really violent scene. Every single thing that anyone does will piss you off.
That was the lady who asked the question. She's now wishing she didn't because she thinks James had about 2 or 3 hours of sleep the night before and is going to do a serious Sopranos on her. But I think, just joking aside, I think sleep has an enormous story to tell in the future treatment of psychiatric conditions. I think we're only now starting to understand how sleep provides those emotional benefits, and I think that will translate very quickly into our understanding of the relationship, the intimate association between sleep and mental health. So I should probably start to wrap it up, and when you think about why you should sleep and what is the piece of mental furniture that I would like to dispose on you as I walk away from this talk, well, I think what we've certainly understood tonight is that sleep is essential both for your brain and for your body health. In fact, there is not one tissue within the body, there is not one process within the brain that is not beneficially gifted something by sleep when you get it, and detrimentally impaired when you take sleep away. I've shown you evidence within the brain that it's critical for learning and memory, it can inspire creativity, regulate your emotions. And I didn't have the chance to tell you about sleep in the body with cardiovascular health or metabolic control, but I certainly showed you an example that hopefully had some impact in terms of your immune health. In fact, the single most effective thing you can do each and every day to reset your brain and body health is to get a good night of sleep. And I think perhaps, excuse the pun, it's time that we in these industrialized nations started to wake up to that fact. So I will finish there, and I will thank all of my lab members. I actually don't do any hard work. I just drink tea, I write emails. They do all of the hard work, and then I come to talks like this, and I pretend that their data is my own. It's not at all, and I'm immensely grateful for everything that they've done. And finally, I noticed some of you stayed awake during this talk. So tonight, after all of this information, I hope you sleep well. Thank you very much indeed.
All right. We've got some time for some more Q&A. The first question goes to Tucker.
Thank you, Juliana. Professor Walker, we were told that moderation in all things is to be sought. Aristotle, I guess, was one of the early great minds that said that. Is that true with everything except sleep? Can you get too much sleep?
So, as this sort of comes back to the question of hypersomnia or excessive sleep. And as I said right now, the data has question marks over it. My suspicion is that the answer is yes, that you can get too much sleep. Just like you can get too much wakefulness. And the brain is optimally designed us to have about a 1/3, 2/3 split, about 16 hours of wakefulness, about 8 hours of sleep. And I think if you push the boundaries on either one of those, biological detriments will ensue.
Is it physiologically possible, though, to sleep longer than 8 hours or 10?
So is it physiologically possible to sleep longer than 8 hours? This comes really back to the individual needs. Some people naturally need about 10 hours of sleep a night. It's just like asking what is the average amount of calories that each person should consume during the day? Well, that depends on your physiology and what you've been doing. I could give you a stock standard amount, which is 2,000. Just like I could give you a stock standard amount of 8 hours of sleep. But it's going to differ. So some people certainly can routinely sleep 10 hours. Some people can sleep maybe just 7 hours. What I will tell you is that once you start to get below 7 hours of sleep, we can almost always measure objective impairments in the laboratory. And here's the problem with that. These are the people that say, no, I can survive on 5 or 6 hours, I'm fine. Your subjective opinion of how you're doing with too little sleep is a miserable predictor of objectively how you're doing with too little sleep. So the analogy would be the drunk driver at the bar. He's had 6 shots of vodka, he picks up his car keys and says, no, I'm completely fine to drive home. No, I know that you think you're fine, but trust me, objectively you're not. That's the very same situation that we find with sleep and sleep deprivation.
So I would like to get some of the folks that did not get their questions answered the first time around. So please raise your hand if you're in that category. You were trying and we didn't get to you. Okay. Let's stick with the questions that are on the mic for now.
Is the mic on?
Yes. Yeah, you're good.
I have had several friends in my lifetime who claim that they sleep 4 to 5 hours a night. I'm an 8-hour sleeper, and now that I'm old, I'm 7.5-hour sleeper. And I found afternoons taking naps, I can do less than 7.5 hours. But they seem really, really sharp. I mean, they're authors. They write excellent textbooks. I don't understand how they can function so well with so little sleep, and what the reason might be for some needing 10 hours and some needing much less.
Yeah, so it's always hard to sort of to assess that. Usually what we find is that when those people who've claimed to be 5 or 6 hours of sleep a night, if we bring them into the lab and we look at that need, they tend to be sleeping more. But the answer is usually, imagine how much better they could have been if they got 7 or 8 hours of sleep. So certainly, as I said, all we know is that in healthy individuals, once they start to drop below about 7 hours, you can see both impairments in their body biology and impairments in their cognitive psychology. So is there a fact that there are genetic abnormalities, and it's a 0.000 of the population who do seem to be natural short sleepers, sort of 4 hours, 5 hours. But it's almost guaranteed that the people who say they're 4 or 5 hours of sleep a night, they're not those genetic people. It's highly unlikely based on the percentage. Yeah.
So earlier you showed the evidence about the killer cells dying away if you don't get a good night's sleep. Do they come back after you get a good night's sleep?
Yeah, so the question about the natural killer cells, what happens when you get recovery sleep? The upside is that after one dose of short sleep, when you get a recovery night, they will come back and be restored once you've had that recovery sleep. 2 additional points there. Firstly, that doesn't change the fact that during the day when you were sleep deprived, your immune system is vulnerable, and if anything has taken hold, then too bad. The second point is that we just don't know if the immune system can recover after chronic long-term sleep restriction rather than just one night of short sleep. So I'm not trying to scaremonger here, but simply that we just don't know the answers, which is ecologically more relevant in terms of how some people could be suffering from a lack of sleep.
So there was a prevalent attitude in graduate school that it was better to get 6.5 hours of sleep than 7 hours of sleep, because of the point at which you woke up. And I'm wondering if that's true.
There's no good evidence for that. Again, when you wake up could make a difference, but that is often independent of how long you've been sleeping, to a degree. So as long as you're sort of waking up in the early morning hours, on one day you could be waking up from REM, on another day you could be waking up from stage 2 non-REM sleep. It's not so hardwired that it's to the minute. So, actually it's probably just good if I do that. So no, that's a complete fallacy, and I would recommend very much the 7, and if not the 7, certainly the 9.
So with your sleep cycle graph, it showed going down into 1, 2, 3, 4, and then back up into REM. Is it possible to go straight into REM? And if not, like I've had experiences where you take like a 10-minute nap, and you're definitely vivid dreaming, not just sleep thinking. But how does that process work?
So there are 3 answers embedded in your elegant question, and let me see if I can keep them all in my mind. First, it's highly unlikely that you will ever go into REM sleep immediately. The only time that would happen is if you're suffering from narcolepsy. It's one of the narcolepsy is a sleep disorder where you have excessive daytime sleepiness, and you also have paralysis attacks when you experience severe emotion. One of the other features is that narcoleptic patients will often go from wakefulness straight into REM sleep. Otherwise, people who don't have narcolepsy don't do that. The only time that can happen in non-narcoleptic healthy people is if you have been depriving yourself of REM sleep each and every night to the point where you build up so much pressure to go into REM sleep that at some point the brain just shortcuts the non-REM sleep and takes you right into REM. That is a very extreme circumstance. The reason that it happens sometimes with naps, that you can maybe just have 10 or 15 minutes of sleep and already be into a dream period when normally it would take you 90 minutes, is because of the time of day. You remember that graph that you were speaking about where early in the night, it's very unlikely that you have a lot of REM sleep. The later into the night, into the early morning hours that you go, the more your brain desires and hungers for REM sleep. So therefore, if you start to take naps late in the morning or early in the afternoon, your brain is still in its appetite desire phase for REM sleep. So it will arrive a little bit earlier. It's still very unlikely that you'll jump directly from wakefulness into REM, but that REM could come earlier than 90 minutes is likely relative to then, for example, 11 o'clock that following night. By the way, I'm going to elegantly segue into the alcohol thing. So there's actually 4 things. In fact, there's 5, because there's always one thing that you don't know. So the 4th thing, the other way that you can go straight into REM sleep, if you build up enough pressure because you've deprived yourself of REM sleep, how would you do that? Well, one way is alcohol. So alcohol is a very potent suppressor of REM sleep. So some of you, let me revise that. Some of you may have friends who have reported this experience where after a night of a little bit too much drink, they'll tell you that they were having these really bizarre, wacky, intense dreams the next morning. Here's how it works. You've had too much to drink and the alcohol is swilling around in your system and your liver and your kidneys are desperately trying to break it down. Sometime in the middle of the night, as long as you haven't really soused yourself, it will finally have excreted the alcohol in your system. But here's the catch. During that time that the alcohol was in your system, your brain has not been able to obtain REM sleep. But your brain is smart. It keeps a clock counter of how much REM sleep you should have had. So then when the alcohol is out of your system, not only do you go on to have the REM sleep that you would have had normally, the brain tries to get back some of it that it lost when it was doused in alcohol. It's called a REM sleep rebound effect. So if you do that night after, and so as a consequence, you get these really intense REM sleep periods and hence dreaming late in the morning. It's a little tidbit at the dinner table, I'm sure. So if you were to repeatedly be doing that each and every night, that's one way that you can build up so much pressure for REM sleep that you'll immediately go into it. Something else that's interesting, in alcoholics, they have a phenomena that's called delirium tremens. And this is where they start to have sort of hallucinogenic psychotic experiences when they're awake. What we now think is happening is that it's REM sleep bleeding through into waking life. The alcohol has suppressed REM sleep so much that the brain just says, I don't care if you're awake, I'm just going to take it if I can get it. So you start to dream when you're awake. Not the same way with caffeine. Caffeine works in a completely different way. Caffeine just keeps you awake. Here's how caffeine works. During the day, there is a chemical that builds up in your brain. That chemical is called adenosine. The more of it that builds up, and it builds up in this exponential manner, the more you want to go to sleep. And then when you go to sleep, and so it builds up what we call sleep pressure. Adenosine is the sleep pressure chemical. It's a good thing that will get you to sleep. When you sleep, it's as if you release the pressure valve and you remove the adenosine, so you start to wake back up again later into the morning. The way that caffeine works is that caffeine comes in and jumps onto the receptors in your brain that normally adenosine latches onto. So caffeine will block the receptors and prevent your brain from sensing how much adenosine has built up. So you're going along, you're starting to feel tired, you have a cup of coffee, the caffeine jumps onto the receptors and fools your brain into thinking there is not as much adenosine hanging around. So your brain thinks, oh, hang on a second, I thought I was really tired, but now it looks like there isn't as much adenosine around, so I should wake up again. The problem is that the adenosine continues to build up as you're drinking that coffee. So when the caffeine finally gets removed out of your system, you crash. Because now your brain gets hit with a double dose of adenosine. Not just the adenosine where it was before when you started drinking the caffeine, that plus all of the adenosine that's been building up, despite your brain not realizing it, because it's been blocked by the masking signal of caffeine. Is that understandable? That's not why you get a headache. There are different side mechanisms related to caffeine due to vasoconstriction issues and vasodilation issues. I can take another.
Sure. Hi. When you're working with research subjects, what's the longest you've ever sleep deprived someone, and how long are you allowed to sleep deprive them before somebody comes in and sues you or whatever?
So I've been in prison 3 times now due to no. So you can usually sleep deprive, and the way we do it was, as I said, no naps, no caffeine. Most people think they can do 1 night of sleep, but they do it with naps and caffeine. When they do it our way, it's tough. After the 2nd night of total sleep deprivation, it is very difficult to keep people awake. The military can get away with about 80 hours of sleep deprivation. That's usually 3 to 4 nights they've been doing that. It's very difficult. The world record is, well, actually, there isn't a world record. The reason is because Guinness has stopped recognizing attempts to break the world record because they realize that sleep deprivation is such a severe, debilitating biological state. They won't so they'll let people jump out of planes, they'll let them go up to outer space in an air balloon and then dive back down to Earth. That's okay. They'll recognize sleep deprivation. No. The records right now, the unofficial record is about 11 days. But there are interesting case histories of people who've tried to break the world record for sleep. There's a famous one in the 1960s. There was a disc jockey in New York called Peter Tripp, and he was going to try and break the world record for sleep deprivation, which at the time was 8 days straight. He was going to do it for the March of Dimes for charity. He was a perfectly stable guy beforehand. By day 4, he started to have severe hallucinations. He went into a paranoid state where he thought people were trying to poison him. By day 8, he was almost impossible to work with. He was finding all sorts of ways to try and work around the doctors and the psychiatrists to try and grab some sleep. He then slept for about 22 hours straight, woke up, read the New York Times, and seemed to be completely fine. It turns out that his wife then started to notice significant behavioral changes. Peter Tripp wasn't Peter Tripp anymore. He then subsequently had such behavioral problems that he went through a nasty divorce, he lost his job, and the last that people heard of him was selling books to door in the Midwest.
So the sleep that you get from Ambien and other sleep aids, is that as good as normal natural sleep? Do you go through the same cycles?
It's a great question. So the older sleep medications, what we called the sedative hypnotics, when you were using those, it was very clear that you weren't awake. But you were not asleep either, really. If you look at the physiology of the brain, you were simply sedated. And sedation is not sleep. The newer medications, those that you describe, and I'm not going to name them for legal reasons, but the newer medications that are coming online, they may produce somewhat more naturalistic sleep, but if you again look at the physiology, it's still not the same. And some of those medications seem to not let you get into deep sleep, and they will actually reduce the amount of REM sleep that you have. And what's remarkable is we actually don't know the functional consequences. Millions of people tonight will take those drugs. And people like me, doctors and scientists, we don't know the answers. The government, NIH, they may not be that keen to fund these studies, rightly so, because they think it's the purview of the drug companies. You can imagine the drug companies may be not that keen to figure out what their sleep medications are doing. Who wants on their label, their drug sort of label, you will get a solid 8 hours of sleep, but you won't remember anything from yesterday. You know, sort of. Now I'm not saying that that's the case. I'm just simply saying that we actually don't know. I only know of one study that was looking at how the brain can actually rewire itself during sleep. It's the basis of memory and learning. And what they found is that with these medications, yes, you slept, but not only did you not get the benefit that sleep was helping in terms of rewiring the circuit, it actually undid the learning that was produced during the day when you were awake. The reason that I find that striking and shocking is because the age of prescription for sleep medications is coming down. And so I think we need to be very careful about our recommendations for sleep medications when it comes to things like education, learning, and all of that. I think it concerns me.
Why did evolution develop sleep? I mean, what is the survival benefit? Wouldn't it have been better for evolution to develop a brain and body that just runs continuously?
Yeah, so there's a great quote by one of the founding fathers of my field, a guy called Alan Recksheffen from Chicago. And he once said that if sleep doesn't serve an absolutely vital function, it's the biggest mistake evolution ever made. And when you think about it, you're absolutely right. It is the worst idea. You're not finding a mate, you're not finding food, you're not reproducing, you're not socially interacting, and worst of all, you're vulnerable to predation. On any one of those grounds, sleep should have been selected against. The fact that sleep is present, as I said, in almost every species that we've observed tells us that it must be still important. Whatever benefits it provides, they outweigh all of those catastrophic detriments. And now, as I said, the question isn't so much anymore, what does sleep do? The hunt is actually, is there anything that sleep doesn't support? And that essentially gives probably the answer as to why it has persisted in evolution.
What the heck is yawning?
So, interesting. Yawning seems to be at least at one level, and it's still debated. It's surprising, but one argument is that it's about an inspiration of oxygen because the brain sometimes can lapse into sleep-like states when it becomes devoid of oxygen. So that's one of the arguments. The other is that it's about changing the respiration of your body, which can also help with alertness. What I will tell you is that yawning is contagious. We now know that scientifically. In fact, it's cross-species contagious. And they've done these studies, I kid you not, where the owner of the dog has been sitting in the chair and they're monitoring the dog and they're waiting for it, and the owner does this, and then, sure enough, 1,000, 2,000, bang, the dog yawned. And it really is reactive. Statistically, it's reliable. So we don't quite yet know the function. We've got theories about the function of yawning. What we do know, highly contagious.
Yes. Is there anything that mimics the benefits of sleep, either drug or activity that might mimic sleep benefits?
Right now, we know of no pharmacologically induced or no behaviorally induced things like meditation. No mechanism that seems to co-opt the remarkably complex biological ballet that is a night of sleep. And it is remarkably complex. I showed you just the basic but highly nonlinear structure of sleep. It gets even more complex when you, for example, measure the brain chemistry. There are remarkable changes in the neurochemical cocktail within your brain during those different stages of sleep. Incredible bursts and trains of electrical activity. The patterns of brainwave activity, the neuroanatomy of sleep is demonstrably different during those different stages of sleep. To think of anything other than sleep being able to produce that, like a simple pill, is just an absent-minded act. It's probably comes from a mind that's sleep-deprived.
I have a quick question. So there's been discussion of the evolutionary basis for sleep, and there's been discussion about sleep's connection with daylight. Has there been any study on the difference in sleep between animals that have evolved, say, at the equator, where daylight is more constant, versus animals that are closer to the poles, where daylight fluctuates, and their sleep habits? Also, hibernation.
Yes, so hibernation is interesting from a sort of an energy expenditure point of view, although, by the way, sleep doesn't actually help you save very much energy relative to simply lying on a couch but remaining awake. So one of the old ideas about the function of sleep was just to save you energy. But if that was true, why lose consciousness? The additional savings that you get from going to sleep versus lying completely still for 8 hours but remaining awake is only about 150 calories. It's about the slice of a piece of brown bread. So the idea that evolution would help you lose consciousness for such a small amount of calorie saving, I mean, you just go out and club another baby seal and eat some more, and then you wouldn't have to fall asleep and fall prey to all of the detriments that sleep supports. So the energy side of it is a very interesting one. Certainly there are differences in terms of the sleep patterns that we see as people transition from the equator. One of those is something called SAD, which is a disorder, SAD. It's an unfortunate acronym, but it's called seasonal affective disorder. And it seems to be related to an abnormality of your biological rhythm because you are no longer getting the reliable 12 to 16 hours of daylight rhythmic activity. And your biological rhythm becomes dysregulated. And as a consequence, your sleep rhythm becomes dysregulated. And you start to suffer from depression. And one of the treatments for those people in those high northern or low southern regions is to wake up early and have a huge light box in front of them that hits them with the strength of lux, which is a measure of light, to help give them back that light signal to entrain their biological rhythm. So we can certainly see that species will change with their rhythmic activity depending on where they sit in terms of the globe. But if we as a species may have evolved around one place on the globe and we shift to another, there seems to be psychiatric complications that come because of that change in the biological rhythm. So it's a fascinating point that maybe we're not supposed to be living in England. Maybe we're supposed to be living in San Diego. I should take a leaf out of that book. I'm getting closer. I'm in San Francisco. It's better than Liverpool, put it that way.
We've got time for one more question, so I'm going to give it to Herb to take us out.
What about cases of sleep disruption? And I'm thinking like chronically like a firefighter that's constantly woken up, but long-term consequences for frequent sleep disruption.
Yeah, so people have studied professions where sleep disruption is rife. One of those is actually airline pilots and the stewards, the airline, what's the correct name for it? Flight attendants. Thank you very much. That was a remarkably 1960s description of what they are. Sorry, it's just a good job I'm not on camera. So what they found was that there are certain parts of their brain that showed significant deteriorations in structure, we presume because of a lack of sleep and because of their sleep-wake rhythms being so disrupted. And what was interesting is that it wasn't just that relative to age-match controls, they had that brain damage, but the severity of that brain damage correlated with the duration of years that they've been on that job. So it really lends further evidence that correlation is not causality, but you're getting close with that. So there are significant consequences to professions that suffer from a lack of sleep. And imagine some of the functions that I've described: sound decision-making, stable emotions, good learning and memory. When you think about professions that suffer a lack of sleep, the military, aviation, doctors, nurses, I mean, do you want a surgeon who has been on call now for the past 40 hours trying to sort of open you up and perform some sort of technique that requires a lot of skills and a lot of knowledge brought to bear? In fact, there was a recent call for a change in medical practice where you could actually ask your doctor how long he's been awake before he performs the operation. And if you choose to, you can cancel it until he's had enough sleep. And if you look, the evidence is remarkable. If you look at the relationship between those medical disciplines where sleep deprivation is rife, the amount of medical errors track perfectly with the lack of sleep. And what was interesting is that we've had this data for a long time, and we've been trying to speak to the medical community to see if they can change this mentality, this old boys network mentality, that, well, we as surgeons, we're a special breed. No, you're not a special breed. Thousands of years of evolution have demanded that you have 8 hours of sleep, and you think with a couple of years at medical school, you're going to be able to reverse the demands of evolution from thousands of years. It's a foolhardy idea, and the data is there to prove it. So people in my field have tried to battle the medical community to switch their practices. And it was interesting, at first, if you look at the medical errors from the patient point of view, it doesn't have much traction. You're using the wrong language. If instead you speak about the dollar cost in terms of malpractice, people start to listen. And now they are changing the resident hours. It started in Massachusetts, I believe, and is now spreading for the good. So I don't mind whichever method, whichever club is required to bash these people over the head to make them change these practices. As long as it's happening, that's the most important thing. So I think I will let everyone sleep. Thanks very much again.
So I'll live each day